Okay, so let's say that you wanted to do this lab analysis using a spreadsheet. So anyone can do this. People who are doing this remotely, however, have another advantage because they can enter their data directly into a spreadsheet. So I have filled in all of my data, and it might look pretty confusing, um, but take a minute to look at everything. M1 and M2 are the two masses of the objects. V1 and V2 are the initial velocities. I changed the masses of each part, excuse me, the initial velocities, and I got some final velocities. Now, I chose an elasticity of 0 because I made up all of these numbers. And so it's actually easier to make up numbers if it's an inelastic collision. So I chose an elasticity of 0, and so you can see all the final velocities are the same. So there's a couple things you want to understand here. Spreadsheets, when you enter a number, will round the numbers off to get rid of any unnecessary zeros. That's not what we do in science. So we want sig figs. So, whatever the website said for speed, here was the O physics site. It is actually like whole numbers of masses, but if you click on the slider, you get an extra decimal point. Same kind of thing if you do the velocity. So all the velocities and all the masses should really be to the 10th place. So the quick trick for that is to highlight all of the things you want to um, modify there. And actually, it's different for the lab analysis. And there is a button, and I always forget which one it is, so I hover over it. Increase decimal and decrease decimal. Under the type of thing you have, these are numbers, and that automatically changes the number of sig figs. But if you want it to be reflecting of the data you have in the simulation, you want it all to be one decimal place. So just pause that and watch it again if you want to see it again. For the final velocities, if I go back to that simulation and let them hit one another, I get all this decimal place junk. So 3.576, I got to the 1000th place of velocity. So it's not a great simulation because the accuracy miraculously increases when that happens. So, what I'm saying is I made up poor numbers here. I want 3 decimal places, and so I want 1.667 and 1.667 there. I want 0.167. No, that one's fine. And this is 1.333, and this is 1.333. Okay, so that's better. So you want to have your data reflect the number of sig figs. So that's one way to do it, is to change the decimal place. And then there's the meta of calculations. So if you want, and this goes, this is for everybody. If you want to turn in your lab and have the data tables be like Excel spreadsheets that you then, you do your calculations right in there, it can save you some time. Now, it might not save you a ton of time in this lab because you're basically learning how to do it on the fly while you're doing it. But in the future, this sort of thing saves you a ton of time. So I entered my data, and what I wanted to show you is how to calculate the initial and final momentum of your system using a formula. So, if you hit the equal sign, it starts a formula. You can do 3 times 8, and when we hit enter, it does the calculation. So if you want to do a calculation, you start with an equal sign. The other thing about spreadsheets is if you start the equal sign and then you click on a cell, it will put in the designation for that cell as the value it wants to be. Now, if you wanted to multiply everything by 100, you would then do that cell times 100. And if you haven't noticed, the multiplication symbol in a spreadsheet is the asterisk, not the letter X, so that doesn't get confusing. Okay, so we want to do initial momentum. So we have this equation that initial momentum is m1 v1 plus m2 v2. So I'm going to start a formula. And again, please pause and rewatch this as much as needed. But I'm going to do the following. I want to do m1 times v1. So I'm going to click on the value for m1 for that trial, type in an asterisk, and then click on the value for v1. Now, both of those cells are highlighted and they are multiplied together. So that's m1 times v1. The rest of initial momentum is plus m2 v2. So I put in a plus sign. I click on the value of m2, the cell where it's at, and multiply that by the value in V2. So, you know, it color codes them in Excel and Google Sheets so you can see like which one's which. But that is M1 V1 plus M2 V2. If I hit return, it will tell me the total momentum of the system. And that's awesome. But it gets better. So if you want to, you know, if you want to edit your formula, if you just click on the cell, if you double click on it, it will put you in there. Be very careful. Like formulas can get messed up very quickly if you start to type in them. So if you don't want to change anything, just hit the escape key and it will like cancel any changes. Alternatively, up here there's a formula bar for you, and you can like skip around um, and edit that formula however you want. Okay, so I said it gets even better. So if I like double click on this, I can see like all the cells that I highlighted here. And I now want to repeat this calculation for every trial. And so this is one of the magical things about spreadsheets. If I click on the number 10 that I just calculated, there's a tiny green square in the bottom right-hand corner of the square. I'm like hovering over it now. So see how like my cursor is like a white cross, and when I put it over that square, it becomes a black cross. That means like the functionality of my mouse is about to change. So, and actually Google Sheets will recommend this. It'll like try and autofill for you. Excel makes you do it yourself, whatever. So if you hover over that little square and you click and you drag down, it will repeat the calculation for every row in your column. Now, obviously these numbers are different from one another. So if you want to like inspect it, I'm going to click on the number, I'm going to double click on the number 15, and it shows me what it just did. So it did D6 times F6 plus E6 times G6. So when you do that little click and drag, it will calculate it, but it will move your selections, right? So in the first trial, it used the fourth row to calculate. And in the third trial, it used the sixth row to calculate. So it will like recognize that since you're moving down in the data table, it will repeat the calculation for every row. And so that's the momentum. Now you still have to show your work, and you still have to do sig figs, which is kind of tough. So this is a little bit of an issue because that's a different number of sig figs for each one. So you can't you have to like be careful with this. The number 10 is really awkward. So you have to do like 1.0 times 10 to the second, but you can do 15 is fine. And then for the rest, you would want to, let me see if I can actually do this correctly. For like the numbers 6, 8, and 1, you'd want to increase that to 2 sig figs for each one. So really just the number 10 is the issue. And then you can do the same thing for final momentum. Final momentum is M1 V1 prime plus M2 V2 prime. So I can start an equals sign, click on M1 asterisk V1 prime plus M2 asterisk V2 prime, hit enter. Oh my gosh, it's like really close to 10. I must have done something right. So that's the final momentum of my system after the calculation. And then I drag down and the rest of the values show up. Again, you want to make sure you're doing sig figs. And for most of them, that's fine. For the 10 and the 15, you want to go one more. And if you look at that, when I rounded this to the same number of sig figs, they're exactly equal. So this is something you can do with any lab for spreadsheets. If that was interesting and you want to like see more things that you can do in more kind of diverse ways, let me know and I will make more videos. Otherwise, thank you for watching.